Our paper introduced code shaping, an interaction paradigm that empowers programmers to edit code using freeform sketch annotations on and around code. The system used generative AI to translate unstructured sketching into code edits. We demonstrate how programmers can utilize the code shaping concept supported by future code editors. First, the users want to explore and preprocess data and draws bar chart beside the code. The user draws an arrow from the data declaration code to the bar chart, then to the target area where the intended code changes should be made. She adds the word plot to specify the action. The system edits code to plot data distribution. She runs the code and sees the results, noticing the data requires scaling. She draws on top of the output image and annotates where code edits should be made. She then writes min-max scaling, indicating the intended method to feature scaling to be implemented. She satisfies and accepts changes made. To explore code shaping, we developed and tested a prototype system over 3 stages of design iteration. The first stage explored the types of sketches programmers use and the challenges they face. Programmers can generate code edits and run code to see the results in the cancelled output. In the second stage, we enhanced the system to show how the model interpreted the sketches, focusing on how programmers corrected these kind of errors. Users see interpretation boxes beside their annotations and they can commit the changes. Users see the changes in the code diff view. They can press the accept or reject button for each chunk of code edits. We also introduced command brushes for users to constrain how the model should interpret their sketches. In the last stage, we focused on bridging the interaction gap between the code editor and the sketching layer. We introduced the always-on feed-forward model interpretation, leveraging visual cues on editor gutters and highlighting related code syntax to help users effectively understand the model's interpretation. We also introduced some hands and pen gesture. Users can long press or short press to select either code within the editor or items within the canvas. They can also draw check marks or cross marks to accept or reject code edits. Another scenario demonstrates how 2 software developers use the code editor with support for code shaping on an interactive whiteboard to review and optimize code. Carol first wants to flatten the bulk of control statements. The always-on feedforward correctly interprets this, so she commits the changes. Blair approves the changes by drawing a check mark. Blair then tries to merge the queries by drawing how the unified queries should form. Blair finds the interpretation incorrect and adds query equal at the beginning to correct it. Blair commits the change after seeing the feedforward interpretation is correct. Alicia, sitting at a cozy cafe, tablet in hand, launches the code shaping to modify her machine learning pipeline. She starts by sketching a flowchart beside the code to address missing categorical encoding. The system recognizes her handwriting, interpreting the if-else control logic. Alicia commits the changes and sees the updated code now considers categorical encoding. Realizing she needs further adjustments, Alicia double-taps to undo the screen cleaning and selects part of her previous sketches. She drags the selected sketches down, creates spaces, and adds a new branch in the middle. The system correctly interprets her intended updates. With a commit, Alicia sees the updated code now considers the parameter. She rerun the code, seeing the updated pipeline works perfectly. See more details and study results in our paper.